Okay, finally, here we go. Yeah, we need to talk about a more complicated derivative. And we're going to start off with a not so complicated derivative, and that's the one you see on the screen there at the very top. What is the derivative of y equals square root of x? Well, as we know, we are going to change that. How do we do the square root of x? Or do you know it right offhand? Yeah, that's x to the 1/2 power, right? And when I have x to the 1/2 power, then I can just use the product rule, right? So that would be what derivative? 1/2, bring down the power, x to the new power would be minus 1/2, because you subtract 1. Okay, so remember that right there. If you've got the square root of x, the derivative is 1/2 x to the minus 1/2. Well, the reason I bring that up is because I want to look at the derivative in a new function, that is the square root of x squared plus 3x. So you can see why maybe I talked about the square root of x first, but we'll get back to that in just a second, because it is a square root. Okay? All right, but initially anyway, this is not how we'll do it later on, but initially anyway, look at what I'm going to do. Let's do the derivative using our old friend, maybe not so old yet, but the limit definition. Right? Remember, does that look familiar? The limit as h approaches 0 of f of x plus h minus f of x over h. And the reason I put it together here is so you won't have to write all this out, because it is, as you can see, some of it's kind of long. But let's see if we can work our way through it. Okay, so do you see where all this came from right here? I've got two square roots. Why do I have two square roots? Well, this square root right here is the f of x plus h, isn't it? Because if I plug in x plus h into my x squared and 3 times x plus h, isn't that what I get? Okay. And then the minus, well, that's just f of x, the square root of x squared plus 3x. With me so far? Over h. Okay, well, how do I do that limit? Well, it's a square root minus square root. Do the conjugate, right? Which that's what I do right here. Multiply by the conjugate. Square root plus square root, top and bottom. All right? What happens when I multiply the top? This times this. What happens? Well, the square root times this square root. Don't I wind up with this? The first square roots multiplied together. The second square roots multiplied together. Wind up with this. And then, of course, the bottom, I just leave it as h times the square root plus the square root. Okay? All right, on step 4. Line 4. With me, any questions so far? All right, well, let's do a little bit of simplifying here. X plus h squared, square it out. X plus be x squared plus 2xh plus x squared, h squared. Multiply the 3, so you get 3x plus 3h. Distribute the minus, you get minus x squared minus 3x. What happens? Lots of canceling. 3x's go out. The x squareds go out. And we wind up with 2xh, h squared, and 3h, which all have an h. So if I pull out an h, I wind up with 2x plus h plus 3 over h times the square root plus the square root. What happens there on line 6? The h's cancel. And so I'll wind up with something I can now do the limit as h approaches 0 to, because h goes to 0, this goes to 0, this goes to 0, this goes to 0. So I wind up with this. I wind up with, all that's left in this first square root is x squared plus 3x, right? X squared plus 3x. Second square root is plus x squared plus 3x. On top, all I have is 2x plus 3. So here's the derivative. Notice these two square roots are the exact same square root, so I can combine them into That's one square root plus another one of the same square root. So that's 2 square roots of x squared plus 3x. Okay. All right. There's your derivative. Well, let's change up the form just a little bit. See what I did on line 9? I moved this 2x plus 3 out, and I'll show you why I did that in a second. Then on line 10, what did I do? Well, then I just rewrote this square root on the bottom as minus 1/2 power. Isn't that right? I can do that. Okay. Why did I do that? Well, do you see a correlation, at least in this part, and then the original very top one I did? 1/2 x to the minus 1/2, what do I have down here? Basically the same thing. I have a 1/2 x squared plus 3x to the minus 1/2. The only difference between that and the one on top is here, I started with x to the 1/2. Down here, if you put it in those terms, it would be x squared plus 3x to the 1/2, wouldn't it? So this derivative at the top, isn't it very similar? Got a little extra, but it's very similar to that. Yeah. What this part winds up being, this is just the derivative of the square root part, the square root, the 1/2 power thing, right? Because notice here, I started with y equals, let's just write down here, x squared plus 3x to the 1/2. So isn't this part right here, bring down the power and subtract 1 from the power? Isn't that what that is? 1/2 is bring down this power and then subtract 1 and you get minus 1/2. That's just the derivative of that square root of the 1/2 power. Now, the question then is, what is this? 2x plus 3, where does that come from? Do you notice anything about? Hint, hint. Aha! Look at the inside. If I do the derivative of the inside, isn't it 2x plus 3? It's the same thing with the square root of x because the derivative of the inside is 1. Yeah, it's really the same. You're right. Just you didn't have to think about that because it's 1. Okay? All right. Well, here's the story on this. This is called what's called the chain rule. Because the way I like to think of it, yeah, we did the derivative of the inside, but if we think of it, this is the inside, and then the 1/2 power, that's the outside function, so to speak. Thank you. The 1/2 is the outside. The x squared plus 3x is the inside. This part out up front here is the derivative of the outside. That part I've got circled first, and then the second part I've got circled is the derivative of the inside. Now, please note, on the derivative of the outside part, what happened to the inside part? The inside part is x squared plus 3x, and then the inside part on this first is x squared plus, what happened to the inside part? Not a thing, okay? The inside part stayed the same. This is called, this little process right here, this is called the chain rule. And you use the chain rule when you have these complicated things. When you have an inside part and an outside part, you've got a complicated function. When the inside part is not derivative of 1, you have to use here what is called chain rule. Chain rule is what this is called. That's our new rule. New rule is called the chain rule. It's a very important rule because it'll come up in a lot of places. This one's a pretty complicated one. They won't all be necessarily as complicated as this, but it's still going to need to be done. So the chain rule is, it's a rule you use. Let me move on down here. So the chain rule, just some things about it. All right, so this is a rule you use when you have an inside part and outside part. Or an outside and inside part. Other than just X. You know, the deal is on ours, like you pointed out just a second ago, the deal is the ones that we've been doing, we've had an inside part, it's just that the inside part was X. Now the inside part is going to be more than just X. It may not be a whole lot more, maybe 2X or something as simple as that, but if it's something, the inside part is more than just an X or whatever variable. So yeah, here it is kind of, this is not by any means a technical way of doing it, but it's just like we stated. For a function, y equals you got an inside part and outside part. The derivative by the chain rule is this. You do the derivative of the outside part, usually first, and then multiply that by the derivative of the inside part. That's the chain rule. Like I said, not in technical terms, but that's what it is. Derivative of the outside times the derivative of the inside. And then, of course, special note here, on this part, the inside part stays the same on this part. Okay? Now, in more technical terms, here, let me show you this. You might see this somewhere else. So, this is kind of how we can write a scenario where we need the chain rule. You see that? Say we've got this function where, do you see what I've got? The g of x, hey, where'd you come from? The g of x is my inside part, and the f of that is the outside part. So I've got two parts, f and g is on the inside of the f. So g is the inside, the f is the outside. So this is kind of how it's written in more technical terms. So by the chain rule then, the chain rule states the derivative of y prime, equals, well, you do the derivative of the outside, so that would be f prime, and the inside stays the same, times what? Derivative of the inside should be g prime. So this is how it would look if you if you put it in more mathematical terms. Does anybody know what this f parentheses g of x is called? It's called a composition of functions is the way you represent a chain rule, but that's just FYI. Okay? All right, so let's do some more examples here of using the chain rule. All right, so let's say we've got g of x equals the fifth root of x squared minus 2x minus 9. Is that a chain rule? Oh yeah, that's a chain rule. And again, the point is on these, if you have these root ones, it's probably best to write it as a power. How would I write the fifth root as a power? It's the 1/5 power, okay? So it's x squared minus 9 to the 1/5 power. So yeah, hopefully, clearly you see here, I do have an inside and outside. What's the inside? Well, x squared minus 2x minus 9 is the inside, and then the 1/5 power is my outside function, if you will. So the derivative, by the chain rule, is I take the derivative of the outside, which I'm just now going to do the derivative of this 1/5 power. So what's the derivative off of this 1/5 power thing? Bring down the power, be 1/5. Leave the inside alone, x squared minus 2x minus 9, because I'm just doing the derivative of the outside right now. And then I do a new power. What's the new power? Well, it's 1/5 minus 1. What's 1/5 minus 1? It's negative 4/5, isn't it? With me on that? But now I have to do this extra step. What else do I have to do? This is just the derivative of the outside. Now I also have to do the inside. What's the derivative of the inside? 2x minus 2. Yeah, now the inside is just x squared minus 2x minus 9, so the inside is just 2x minus 2. Okay? What they might do here, you don't have to, I don't really require it myself, but what they might do is, you see this minus 4/5 power right here, doesn't that mean flip it down, move it to the bottom? And so this 5 being in the bottom, I could, and then the 2x minus 2 would be on the top, so I could write this very well, 2x minus 2 over 5 times x squared minus 2x minus 9 to the 4/5 power. That would be an alternative way of writing that. Follow that, okay? Questions or concerns? All right. Whoop, didn't mean to go that far. All right. Here's another one. Number 2. Y equals 3x y equals 3. There you go. Okay. Y still didn't do what I wanted to do. All right. Y equals 3x minus x squared to the 4th power. Actually, this one might be a hair bit easier. What's the derivative there? Well, this one's already set up, isn't it? Inside and outside. What's the inside? What's the outside? 3x minus x squared. That's the inside. 4th power is my outside one. So what's first? Well, do the derivative of the outside. The derivative of that 4th power thing. Bring down the power. It's just a power rule. Bring down the power. Inside stays the same. Subtract 1 from the power. However, there's another part. The other part is I have to do the derivative of what's on the inside. 3x minus x squared. Derivative is 3 minus 2x. Okay? So some are just really that easy.